All right. Hello, everyone. Welcome to NC-CAV seminar. I'm so excited for everyone who is here today. We have an amazing speaker who will be doing their presentation on analyzing the unseen modular open source geospatial data science ecosystem. We have Dr. Jinha Zhang here, and I will pass it on to Ali to introduce you.
Thanks a lot, Christina. And thanks everyone for being here. My name is Ali Hajbabai. I'm an associate professor and associate head for research and infrastructure in the civil engineering department at North Carolina State University, and we participate on NC-CAV. We are very privileged and happy to have Dr. Jinha Zhang here. He is an associate professor in the Civil and Construction Engineering School at Purdue. He received his PhD degree in geomatics in civil engineering, specializing on computational science and engineering. He got that in 2011. And then he started as a postdoc research associate at the University of Illinois at Chicago and Purdue University, and worked as a faculty at Texas A&M from 2014 until 2019. In 2019, he joined Purdue University. I'm gonna read the topic of the talk one more time: analyzing the unseen, modular open source geospatial data science ecosystem. Very nice topic. The floor is yours, and we are ready to hear your presentation.
Give me a second. Let me share my screen really quick. Okay, and I need to pull up, sorry, all this in the video panel disappeared. I make sure that this video screen is showing up. So thank you, Ali, for the great introduction. It's my honor to have a chance to give a presentation at your seminar series. As already mentioned, the title of my presentation is Analyzing the Unseen Modular Open Source Geospatial Data Science Ecosystem. And hopefully, I know that your group is in transportation oriented in the group. So I don't have that many examples from transportation, but I do have a couple of examples that I'd like to share that I've been involved in here, Purdue side. But this presentation is more about how to make your geospatial data set available and also accessible to a computer, so that you can do big scale data analysis. And I'd like to acknowledge my co-authors of this presentation. My name is at the top, Benjamin Hancock. He is a lead developer from my group, who's been working on developing this open source ecosystem that I'm going to be demonstrating today. And Min-Young Zhang, she's also a postdoc research associate in my research group. So I want to start my presentation from the quote that I heard very recently. I'm going to say that was about a year ago. Somebody from UK came to Purdue and gave a seminar, and I heard this terminology for the first time, and I fell in love. And this is the term called the seeing the unseen. And how many of you remember the moment when you saw something for the first time that you got so excited about it? And I'm hoping that I can give you a similar experience, you guys today. And I'd like to play this in the next video.
Yeah. Lani, put them on. Look at mommy. Look at mommy. Ooh, look at I look so cute. Hello, Bubbles. Can you see? Wow. Lani, look at me.
Dad, she looks like Bubbles off of Trailer Park Boys.
Yeah. Show Daddy.
But it makes it look so special.
Oh, you can see. She's like looking around.
Can you see that?
Lani!
Leave them. Don't touch.
Lani!
You need them on so you can see.
Honey, look at Regan.
Can you
see?
Lani!
Look at Regan.
So this baby never able to see their parents' face, but they got to, she got to see face for the first time with this and help of this technology. So my vision or main outcome that I like to get out of this presentation is that I'm going to introduce some technology to you guys so that you will make similar faces like this you can see from the screen at the end of my presentation.
Yeah.
So I'd like to start my presentation by introducing the story that happened not very long time ago. I'm going to say, I'm going to turn my clock back about 600 years ago. And in those times, there are things that we take for granted so much at this moment. These kind of things were not available to everybody. The one that I'm going to talk about is text information. At that time, text information is not available to everybody simply because it costs a lot of money to generate this information. As you can see from the screen, you have to hire somebody to write on a paper manually, and that the information cannot be mass produced, and that is causing a significant imbalance in information. So somebody who has the power or the money to do so can access this kind of information also. And at the time, there's a lot of people who doesn't know how to read this kind of information as well. And this cause a significant imbalance between the power game. So anybody who can access this kind of text information has a lot more power than the others. And that's the reason why in those days, people with this kind of information has a lot more power. For example, the good example that you can see at the bottom right is in a Bible. And those in the Bible, only those noble people can have an access to. So priests has considered as privileged group at that time, because they believe that those priests only they can talk to to the God, because they can read this in the Bible and etc. But something magical happened in about 600 years ago, like I mentioned earlier. And there is a new technology called Gutenberg printing press that came to the wall. And now before it was costing a lot of money to generate this text information, but with this new technology, generating text information becomes so cheap. And these days we can go to the library. We have ton of text information. Anybody can access this kind of text information, and with this technology, all of us has equal access to this kind of information. So this the power imbalance becomes meaningless because of this new technology. And like I mentioned earlier in the analogy where handwritten books was expensive, but because of this printing press technology, now everybody can access this text information. But what about the geospatial data? These days everybody is using geospatial data set, but the pretty much similar situation was happening in geospatial data science discipline as well. The reason is because generating or creating geospatial data costs you a lot of money. First, you need to have a platform to carry sensors, and a lot of times those platform is going to be expensive. I'm just showing an example of an airborne platform where you have a helicopters, airplane, or in a high altitude in an airplane, etc. And if you want to go to the space, you need to have a satellite. But none of this platform is expensive where the regular user cannot afford to have this kind of platform in your arsenal. Not only the platform, but the sensor that goes onto this platform to generate this geospatial data set is not cheap neither. This is an example of airborne camera that can be mounted on an airplane to collect very high resolution multispectral imagery. And usually these kind of sensors cost you in the order of a couple of $1 million just in the sensors itself. So, platform costs you a lot of money, sensor costs you a lot of money. Not only this in the sensors and the platform, you also need personnel to operate this in a platform to process this. So this is very, very expensive the expensive, the data set to generate. And that's the reason why this kind of geospatial data set is, either mainly done by, big surveying firms, or those, spaceborne sensors is, mainly done by, government level. Like here in the United States, we have a NASA, and the European Union, they have a European space agencies. Those are the, big players where they have enough money to, operate this kind of platform, and they generate this geospatial data set with others. And this technology is great because this technology help us to see the things that we've never seen before. And you probably heard of the news about space telescope. This video that I'm playing here is an example of Hubble telescope. They are zooming in to the one corner of the space in the sky. They have almost infinite capability of zooming in. So we started from very, very far away, but we were zooming in again and again. And something that we haven't seen before, then you're going to start to see this nebulous, where this is the place where those stars are being generated. And imagine that this is something that we've never able to see before, but with this technology, now we can see these kind of images. And this was in a video, and if you just turn this into still images, and this is how it looked like using Hubble telescope. And probably you guys heard of the news that NASA launched a new telescope, which is better than Hubble telescope, which is called James Webb. And they actually picture the same region with James Webb. As you can see, I'm just going to go back and forth. This is how we're going to be able to see using Hubble telescope. This is great, but we are not seeing the stars in the background. But we imaged the same location with a new telescope, and we realize that there is a lot of stuff that we've never seen before. And this is great. We can see things that we've never seen before. Sometimes as an engineer and research scientist, this kind of new discovery makes us excited, and give us a momentum to keep doing this kind of development. But what about this geospatial data? I was making a knowledge about we have handwritten text information, but with the new technology like the printing press, generating text information is becoming cheaper and cheaper these days. Thanks to all this drone technology, unmanned aerial vehicles. Collecting this kind of geospatial data set is becoming cheaper and cheaper and easier. This is an example of my research group is collecting LiDAR data mounted on a drone. And so you see, I have the student is operating here. Of course, I have other student out there, but if you want, it just this can be a single person operation as well, and costs you a lot less money than that compared to all the other example that I was talking about earlier. And this kind of simple technology, now I'm trying to emulate what I have shown you using the Hubble telescope. It is nowhere close to that, the magnification that I was showing earlier. But this is on the agriculture field where we're flying high. But as we're getting close to the ground, we start to see a lot of things that we are not able to see from either aerial images or spaceborne images. And this drone technology gives us a technology to look very, very detailed into what is happening on the ground. And this good thing about this drone technology is that now it will generate very high quality geospatial data set for you. But the big problem is it also generates a lot of high volume of the data set. And that's the reason why my research group developed a platform called Data to Science. And this is an online platform where you can actually manage your own geospatial data set. This is an open to public. Anybody can come up and come here and create an account. They can look at their project. They can visualize this different geospatial data product. We can also visualize point cloud and etc. So this is the platform where you can manage your own geospatial data set. So what I want to do is I want to do a quick demonstration of the platform. Like I mentioned earlier, the URL for this website is called the ps2.d2s.org. D2S stands for Data Science, and a PS2 is not a PlayStation 2. It is in a Plant Science 2.0 initiative. This is the actual Purdue initiative that gave me a seed funding to start it on this project. So if you go to ps2.d2s.org, I just logged in here. If I just log out, this is the screen that you're going to see. Click sign up, put your name, email, password, and create an account, and you'll have to confirm your email, and we'll have to approve your account. Once your account is approved, then you can click this login. Then this is the the website that you're gonna see. And when you create login, you're not gonna see anything because you don't have any project in your the account. But in my case, I have access to many different projects. So as you can see over here, I can access 372 projects. To give you an idea about how many people are using, we have currently 570 active users on this system. We have almost 3,000 data product has been uploaded, and total volume that is been uploaded to this system is over 20 terabytes. And if I go to the project map, it'll take a little bit of time because you're pulling this. Not only those 300 some project that I showed earlier, this there is people from all over the world. They create an account and upload their own data set to this platform so they can manage their own geospatial data. And I'd like to show you a couple of the examples. And the one that I like to show you, because this is the civil engineering group that I'm talking to. So this is data that I'm involved where we are developing here at Purdue, SY project, developing wireless charging module for the electric vehicle. And for that one, we are collecting a lot of thermal images. So let me just show you an example of natural color drone imageries. This is in a parking lot that we are testing over here. Once I click this one, you can zoom in, you can see all those detail. But we also have corresponding thermal images acquired over this region as well. So you can see that this is the actual temperature unit. And you can just zoom in to see this detail. You can do side by side. For example, if I choose this one on the left, let me choose version 2, because I believe this is the better data product. I'm gonna use thermal images on the right. As I zoom in, you can see that this painting is shown as low temperature. And let me see if I can go to other location. And you see the shadow is also low temperature as well. So not only we can generate this color images, we can generate different types of geospatial data product. We can just overlay them in a single location and compare them. And if I go to another example, if I go to the testbed dot Indiana DOT here, and if I just turn on these orthomosaic images, this is an actual testbed location where you're deploying this wireless charging module over here. So this was the data set that was collected the right after the installation. So you see all those wires being exposed, and of course right now we just cover them with concrete right now. But you can see all those wire being shown over here. And we also have thermal images collected over this location. So you can see this actual temperature measurement over this location. And we are planning to, this wireless charging module is not active yet, but we actually testing this wireless charging module with the actual, the car that can be charged while they're driving this summer. And we'll be collecting a lot of this data set, so that we can understand this thermal behavior of this wireless charging station and understand the impact of this thermal to those concrete pavement, etc. And another example that I'd like to show you is there is another data set that we collected. It has nothing to do with transportation, but let me just zoom out so that you guys have an idea about how remote this area is. This is the data set we collected in Ecuador. This is Quito, is in the capital. And from here to there, it takes about 3 days to get there because it's such a remote area. We have to take a boat, take a bus, and it was in such a remote area. But anyway, the thing that I like to show you is if I turn on this drone imagery, you're gonna see that just images, but as we start to zoom in, you will start to see a lot of detail start to populate. This is an Amazon rainforest area. You see, there are many different trees. You can see all those individual leaves and etc. We also have LiDAR data set collected over this location, so we can actually generate the height of the trees. So we can see all those in a data product. Generate this data product in the easy share this look at this data product very easy and over here. And some of this data set is around over 100 gigabyte, but then we can access this kind of information very quickly. So in going back to this presentation here, I mentioned about we do have a platform to manage your own data set. And like I mentioned earlier, being able to see something that you have never seen before is great, because it makes me excited, because this is such a unique experience. But this joy of seeing something for the first time even gets greater when we can share this with a lot of people. So not only you can see some things that you have never seen before, more important thing is that how can you actually share things with others very easily. The example that I showed you earlier, Tiptini biodiversity, Amazon rainforest data set that I showed you, this is about 170 gigabyte in size. And what if I'd like to share with you? And what you can do is, the old way of sharing this data set is, this is in a big data set, 170 gigabyte. Probably, one way of doing it is you can just, copy this file in your external hard drive, then send it to somebody, and somebody is going to be, copying their file to their machine and ship it to another location, ship it around. And this is one way of doing it. But of course, this is process that is very slow. Plus, the copying this in a file takes a lot of time to do so. And these days, you don't have to actually, ship this in a physical object around. Everything you can just, stream in from the, cloud. The one good example of, video content is in old days, if you like to watch the video, you have to actually rent a DVD. And this is a Google Trend search that I'm showing over here between 2004 and somewhere around 2010. Sometime around 2004, YouTube was nothing there. But if you like to consume any video content, DVD was the kind of thing at the time that you have to use that technology. But the YouTube was launched, I think, somewhere around 2005 and 2006. This golden cross happened. This YouTube is going to keep going. I only did Google Trend search until 2010. If I'm doing this in Google Trend search right now, 2025, this DVD is going to be nothing. This YouTube is going to high up there. But the point I'm trying to make here is that when it comes to video content, we never download this in a video anymore. We just stream this in a video content to your device right away. Even though you're watching 2-hour long movies, you don't have to download anything, single stuff. As long as you click play button, you can just consume this kind of information right away. And this is the same thing happening in all over the all different types of content. Text information is the same. Before it was in handwritten text. It was in a mass generated printing press. Now everything is digital. You don't need to go to the bookstore to buy it. You can just buy a book from the Kindle store, and it becomes available to your phone, tablet, computer right away. And somebody did a market share search, and when it comes to media players and streaming platform, YouTube has a 98% market share. And if you look at look it up, I'm pretty sure this is still the case. But who has the most subscriber in YouTube? This is TC channel. This is the channel that shows all those valued style kind of content. And that channel has 263 million subscribers. This is information that I got couple maybe last year. So it might be a lot more than that this right now. But you can get an idea how impactful this in a single channel could be. And if you compare this number with all those in a big media player group, like an NBC, ABC, they're not even close. I think those in a big player has somewhere around couple of million is about number of subscriber, but this one has 263, which is a lot more. So what I want to do is that if you just scan this in a barcode using your the phone, what I encourage you to do is pull up your smartphone, turn your camera. If you just scan this in a barcode line over here, let me just do this together. And what I'm going to do is, and if you do so, I'm not going to just do it over here. And what you're going to see is, the images that I showed you earlier. Remember this multispectral data set that I showed you? And you guys don't have an account or anything, but once you scan that barcode, and let me just do, let me show you what I'm doing here. There is a button called the share. If I do so, it is initially set as restricted, meaning that, this is, you have full control, no one else can see it. This is pretty much the same as in YouTube when you make it private, only you can see it. And what I'm doing here is that anyone, I'm making is unlisted. And I just, copy this URL to the chat window. If I paste that link over here, if you click this link, let me just open up a new browser, private window. Give me a second. So this is a private window that I'm not logged in. If I just paste the link, you can see I'm not logged in, but I can still zoom in and I can see all those in detail. Pretty much, this is about 2,500 acre in an area. You can go to any corner, then you're going to be able to see all these high resolution images right away. And that's what I did over here is I just shared this 107 gigabyte data set with you in the form of the QR code. And this is pretty much the same technology as in YouTube. We have a big geospatial data set. We are not letting you download it. We are streaming this geospatial data set to you. So they are only streaming the data set at the resolution that is needed, so you can just consume it. And if I just go to the next example, if you scan this QR code, this will actually open up a browser. Let me just go back to this one here. Let me just close that one out. And if I go to show you, what I'm doing, go to tip TD biodiversity station, then going to LIDAR-all. And I am, where is the point cloud? Oh, not sure why there is no point cloud over here. Oh, now I see. I think I don't have the point cloud, but what I'm just showing here is that I just copy this share URL, and I'm gonna just do the same thing. Probably the link that I provide in the the PowerPoint may not be exactly the same, but once you do so, now you can see this in the 3D point cloud should be available to your window. So let me just paste that link in over here. And what I did is that I essentially encoded this URL into a QR code, and that should be exactly the same one. But anybody who has this link can actually access this data set very, very easily. So I demonstrated about seeing the unseen part and sharing the unseen part. But as a research scientists and engineers, we don't want just be able to see it. But in order for this to be really meaningful, you should be able to actually analyze the data set. So that's the part that I like to talk about. This data to science platform is an open public. You have the data accessibility as well. But pretty much in any data set that has been uploaded to this data to science platform is accessible by other computing platform, and either through this Python module that I'm going to show you. This is also accessible to the QGIS as a part of plugin and etc. But essentially, what we like to do here is that we are providing a modular pipe processing pipelines where you just have your data set uploaded to this platform, but you can write your own code to stream this information to your computing platform, do the data analysis, and generate the graph, do the analysis, and etc. But the thing here is that you don't need to worry about where your data is located. Everything is coming from the cloud. So let me just do a quick demonstration of the features here. This is a QGIS. This is an open source GIS and a plugin. And there is a plugin manager in QGIS. What you can do is just looking for D2S, and we published a D2S browser plugin. In my case, I have already installed, so I don't need to install it. But if you don't have it installed, there's going to be install plugin button over here that you can click to install. Once you install it, then you just open up this up and provide what is the sub URL. In this case, this is the PS2 instance that you're going to working on. What is your email and what is the password? Once you click this login, then this plugin will be connected to this data to science instance that you listed over there. Now you have an access to all those 300 some projects available over here. So for example, I showed an example of the in-dot electric, wireless charging data that we collected. It has 2 different flights over here. If I just click this one, add this, and also a selected map, now we have drone imagery available. But to give you show you an idea, this is actual, the orthomosaic images that is registered to the Google Map. Let me just zoom out. If I just zoom into this corner over here, this is how this Google Map look like. But if I enable this drone imagery, you can see a lot of detail shows up over here, and you're gonna see even some cracks. It's very visible from this one here. Then what if I like to also load the thermal imagery that we collected? Choose another one, add the thermal imagery over here. Then let me just zoom into the corner that we are looking at. And once you add this one as a layer, this is same as a GeoTIFF file on your local machine, so you can do different color map rendering. I can choose magma, for example, and I know that this is going to be temperature units, so I think between 20 and 50. Click apply. Then you're going to see this actual color rendering is displayed over here. If you go back and forth between thermal imagery and the actual orthomosaic images, you see how well these two are co-aligned to each other. You can see all those coil shows up as a different temperature as well. But what we're working on right now is that right now this is covered by concrete. When we just turn this on, this core will generate heat that we like to measure the heat signature from the thermal images. So we're going to use that information to understand the impact of this thermal behavior to concrete and etc. And if I just go to, for example, like to load up that Amazon data set that I showed you earlier, Tiptini over here, then I'm going to choose multispectral, and also if I just click add to map, I told you that this is about 170 gigabyte in size, but we are not downloading all. We're just streaming only the data that is needed to display. So that's the reason why we can just load up so quickly. If I zoom into this area, now they are streaming this data set only for the portion that we're looking at the resolution that is needed. Now you can see that it took a little bit of time, but they're just updating this the region at the higher resolution and etc. So this makes it very, very accessible to any of those geospatial data set being uploaded to your platform. So this is one way of accessing your data set. The other way of accessing your data set is we do provide a Jupyter Hub environment where you can actually write your own code to access all these data sets. So there are many different examples that I can show you, but the example that I'm about to show you has nothing to do with transportation. This is an agriculture example, but I'm writing all this in a Python code. We are just loading all those modules. I'm connecting to this in an instance over here using programmatically, getting all the project, filtered project by the title, then getting all the flight from there, only choosing RGB sensors, and from there, only orthomosaic and the EXG, which is another layer that we calculate out of in ortho. But we are doing some filtering, and based on certain, the condition, we are just doing a clipping of these images. Then I'm just saying that, hey, show me this in the clip images as a part of figure. So what I'm doing here is that this is an agricultural experiment where they have different treatment, but I'm just showing the actual images that is collected 7 days after planting, 21 days after planting, 45 and etc. As you can see from here, you can see that all those plants are growing over the growing season, and you can see this as in a photograph. But the beauty of this one is that you are not downloading a data set to your local machine. Everything is happening on the cloud, and we just do the same thing with different calculation of vegetation indices. The greener they are, there are more vegetation over there. Then you can see that how this plant is growing over the season can be very, very easily programmed calculated as expressed as figure, etc. And the one last piece that I'm going to talk about here is that all those data set that I mentioned here is programmatically accessible, but you can also publish this data set to something called a stack. That repository that we are managing. Stack stands for Spatial Temporal Archive Catalog. This is becoming almost de facto standard when it comes to sharing this spatial data set with with others. So we are maintaining our own stack repo on our the Purdue data center. And not only this tech repo has drawn data set, geospatial data set that from the data science, but they also do have an access to other item data collection. One notable thing that I'd like to let you know is that we do have a 3DEP, which is USGS 3D elevation program. Essentially, this is an airborne LiDAR data collection for the whole United States. And we also have access to the nape imagery. This is aerial imagery collected from the also USGS as well. And we have a nationwide coverage. These nape images collected every 2 years, or dating all the way back to 2012, I believe. So we have a ton of the geospatial data set available. The beauty here is that we can access all these geospatial data set uploaded to the data to science using Python. All this data set is also accessible, through the Python as well. So you can couple your own geospatial data set with the other geospatial data set, very, very easily. For example, if you like to look for the data set, let's say I'm interested in looking for airborne LiDAR data over North Carolina. So I think I need to be careful. Not going to UNC, but let me just go to the rally over here. Then I'm just interested in 3D data. You can also look for nape imagery as well. So let me go down, choose a nape imagery as well. I'm interested in the data set available for this region. If you just click submit, then they will look for all the data set available for this region. For example, this is only nape images shown over here. So let me just, as you can see, you have aerial images and it shows up right away. Let me just remove this one so that we can just look for 3D only as well. Oh, there is no 3D data in North Carolina. I didn't know about this. So let me go to the another location, Atlanta. So let's go to the Atlanta. And let me just zoom in. Let's say I'm interested in Atlanta downtown. If I search for this one here, now you can see that this is, Georgia statewide LiDAR data collected in 2018. If you click here, everything is in the cloud optimized. If you just open this up, you can copy this URL. Then if you just look for the, the cockpit viewer, go here, then paste that link that you just copied and add them as an URL. Then you're gonna see this airborne LiDAR data set for this whole region has been added. So let me just zoom into the area. I don't know. I cannot. I don't know this area, but let's zoom into a random area. let's say this is your area of interest. If I turn this on, turn this around, then now you see that all these airborne LiDAR data set becomes available. They are using also cloud optimized data set, data forming technology. So this is a huge data set. This is statewide LiDAR that can be in the order of hundreds of gigabytes, but you can actually consume this data set very easily. So the beauty of this the stack is all your data set is machine accessible. One example that I like to show you here is that my group has developed a the additional application based on this infrastructure. This is an application that we developed to generate the leaf on canopy height model generator. Airborne LiDAR is collected by 3D program is collected during the leaf off season because they like to know what is the elevation of the ground. But this is good in some sense. But if the people are interested in, for example, the trees, this leaf up data set might not be a good idea. So basically, what we are doing here is that you can go to anywhere in the United States. Let me just zoom out. Let me go to the same region as the one that we looked at earlier in Atlanta. And I'm gonna zoom in to the region. I never run any of this in a program in this region. I'm looking for residential area. So let me see if you can find any residential area over here. Oh, this is gonna be quite challenging one, but let me just give it a try. Let's say I'm interested in this region. And I like to generate the canopy height model. And once I just throw this in a polygon, you can choose either LiDAR and spectral. If you choose this in the LiDAR data set, we have a statewide coverage. This is 2018. So let me try to pick the native imagery close to that time frame. Click submit a job. And what is happening on the back end is that they are actually streaming airborne LiDAR and native imagery to this server using this condition, and they are actually processing this data on the server side and unable to process. Okay, probably I picked the wrong location. I'm gonna just let me go to the another region. Probably let's go to the Huntsville. Let me see if we can make it work. I think that this is the danger of doing a live demo. Just pick another region here. Let me just do this block. And let's do the same thing here. And 2019. And click submit the job again. Hopefully this one doesn't fail. But like I mentioned earlier, they are pulling this data set from the cloud to this server instance. We have the deep learning model to generate the canopy height model leaf on from leaf up data set. In that process, we also delineate the building boundaries, so we have to see where those buildings are. So this is an actual canopy height model generated. This is an actual the normalized digital height model. You see all those buildings. What we are doing is we are trying to delete those buildings so that we are looking at the trees. These are all the buildings that was detected during those process. These are the older actual height value overlaid on top. I'm pretty sure there are buildings below it. Let me see. It might be 3. This is the caveat of the automated program, and this is an actual native imagery that is used to generate this one. But the point I'm trying to make here is that once this kind of data becomes inaccessible, you guys can write a program to consume this information to do very large scale data analysis. So going back to my presentation, my vision for this project here is that when it comes to the video, we never think about where I'm going to upload my video to share with others. That's just upload to YouTube. I'm doing this for pretty much in everything. All my recorded lectures is being uploaded to YouTube. Then I just upload this link to my course website so that you can actually see those kind of recorded lecture later. My vision is when it comes to spatial data set, people think of this data science platform as a platform like YouTube where they're willing to upload their own data set to this platform. Now this becomes accessible from everywhere. And this data set can be used for, all those, geo AI development that is coming in the near future. I'd like to acknowledge all my funding sources to make this happen. Like I mentioned, we're in a big funding, a big part of the funding is coming from Purdue internal, but we had to have a couple of USDA funding that is supporting this, the work. And this work was possible because of team collaboration. Like I mentioned earlier, myself, Minyoung, and Ben is from my group, but there are other people who contribute this project. For example, Dr. Shell and Na Jo, from School of Art. They're doing UX UI, UI UX the design, and also of course a lot of help from the IT department as well. And we do have a website that you can go. There's a ton of information, training video is also available. Documentation is also available as well. So with this, I'd like to stop my presentation here, and will be more than happy to answer any question you might have.
Feel free to unmute or utilize the chat to ask any questions.
Or did I do a too good job where there's no question at all from the audience?
I'm afraid so. Oh, we have one question. It says, thank you for the presentation. Is the location data taken from GPS data?
So there are many different scenarios. Most of the data set that I showed you is collected from the drone, and the drone is is equipped with a GPS. But a lot of times those GPS is not the survey grade GPS. So you can process the data to generate the geospatial data product, but then oftentimes that geospatial data product is not well registered to the true location on the the Earth surface. So in those cases, you have to do some GPS survey, so that you can actually correct those the misalignment issues. But these days, the most some drones that do come with RTK GPS equipped with it. In those cases, that can be the directly georeferenced very, very precisely. So to answer your question, is the location data taken from GPS data? Quick answer is yes, but not just simple process. There's a lot of data processing that need to be done to correctly georeference that data product to correct location. So the question from Basit, can I perform analysis on the platform, or can I push update in and out of the platform? Quick answer is yes. I showed you that in a Jupyter Hub environment where you can actually log in, spin up your own Jupyter Notebook services, and run your code from there. But that's one way of doing it. You can also run your own Python code from your laptop as well. And this, whatever the Jupyter, notebook that you have, it can be run on Google Colab. It really doesn't matter where you're running this in the process. The example that I showed you earlier is Jupyter Hub instances that is managed at the Purdue Data Center. So if you're processing your code from that, Jupyter Hub, data transfer is going to be a lot faster than your laptop that is connected to over the public Wi-Fi, for example. So quick answer to your question, can I perform analysis on this platform is yes, you can. And you can also push update in and out of the platform. Quick answer is yes. You can download your own data product. Once it's downloaded there, you can actually stream that data product to whatever kind of form of your choice. So you can just do both. So what is my favorite feature of the platform? I think that my favorite feature of the platform is accessibility. Once you upload your data, now it becomes available from anywhere as long as you're connected to the internet. So not only I can actually see the data set very easily, share this data product with others is a matter of click, but also streaming this data set to my own Python code, QGIS. It can be streamed to any other web services and etc. So I think a favorite feature of this platform that I like about is, and I really like to use the term called FAIR, F-A-I-R. It is not the FAIR in a sense of actually this fair access. FAIR is an acronym for findable, accessible, interoperable, and reusable. So once you upload your data set to this platform, your data become fair. I think that is going to be my favorite feature of this web platform.
All right, any other questions? Well, thank you, Dr. Zhang, for joining us today and being our speaker. We are so grateful that you were able to do a live demo as well. We got a lot of insight from that as well. And thanks everyone for joining us for this seminar. I hope everyone has a great day.
Thank you for having me.